these guys say this, like we'd have to try to break down what they're saying, because even in the Glob model, that's even the case. Because like you said, if you're on the equator, like okay, all the GPs are on the ground essentially, the stars. So there's GPs of all the stars at 1 degrees north latitude, 2 degrees north latitude, 3 degrees, etc., going on that line of latitude. So if we just imagine the ground transferred to the sky, or the sky transferred to the ground. But if you're at the GPs on the equator, let's say, you would not have to turn left or right. You would just be going dead, straight, pretty much. But then if you go 1 degree north, even on their globe, you would have to, and you start traveling west, you would have to turn your vehicle to the right a little bit. You have to turn your steering wheel, meaning you are making a circle. There was that whole thing with Jaren and Fight the Flat Earth. There was this huge thing where Jaren was trying to tell Fight the Flat Earth that thing right there, and Fight the Flat Earth was saying no, that wasn't the case. And then Fight the Flat Earth ended up actually conceding and saying, oh, yeah, you were actually right. Meaning if you follow latitude, and that means that you're turning to the right. And then if you go 1 degree south, now you're turning to the left. Well, what is a car that's turning to the right compared to one that's turning to the left? Obviously diverging. They're GPs.
What's funny is half the people on his channel too, like hundreds of, it was a half and half, but with the poll he did, like half of the Globers didn't even understand the globe model, that to follow a line of latitude. See, they're just picturing a globe from a God view, right? But that's not the case. If you're, it's kind of tricky, man, when you really learn the model. But I mean, I knew that. I don't know how he didn't know that, as much as he argues and acts like a physicist. But yeah, he argued it tooth and nail, and then he had to suck a egg on that one.
Well, the thing. Let me just say one. I hear you. Let me just say the one last thing, because the thing is, when you're at north latitude, 1 degree north, or if you're 1 degree south, on the ball compared to each other, you're not diverging. You're just one north, one south. But in order to travel around a sphere, you have to turn your vehicle to the right or the left. So either way, in reality, you do have to actually turn your wheel to the right. The thing is, they're explained in different ways. The globe is claiming that it's because the ground is curving away, whereas on a planar surface, you would actually just be making a horizontal turn to the right. So there is a lot of contention with the StarTrails, because there's some overlaps and then differences and then nuance to that. And I understand why, like the arguments that they're making.
It works from the equator. It does work from the equator, Geo, but that's the only place it works. Like I'm saying, that's their only God view is at the equator. If they were going to do stars that are going straight overhead from the equator, or doing. But once you depart from the equator, then that's when the reality hits you of what's happening.
Hey, Gio, maybe show some of those shots I just put in the chat. Those are just straight up at the. Because those are just straight on shots. It's not like a fisheye thing going on. You don't see that with the surrounding land or the trees or any of that. And it's just showing them like they just separate. It's like exactly like an electromagnetic field. They always show that no matter what.
I'll pull it up. Anyone who wants me to pull anything up, because I'm kind of at my computer right now doing this. But I'll pull up. Which one do you want me to pull up?
Good ones in the chat.
All right, I'll start pulling those up.
I just put 10 images in the chat.
All right, I'll pull those up one at a time. Nico, go ahead though. I think Nico was trying to get in.
I don't think that they convert.
Well, let Nico go, bro.
Yes, your car analogy is quite interesting, because is what we see. As you said, the car will be turning to the left, to the right. It will, but it will keep the same distance. Same GP will make a circle. A star will be at a GP at 10 degree latitude north. It will make a circle around, and the one at 10 latitude south will do also. And they will do two circles. But all along, distance between the stars will be still 20 degrees in the sky. You will not see any divergence or convergence of these two stars who make the circle. They stay at the same distance, as you stated before. So, all the contention là is telling that the stars diverge or converge. They do not. You can stay all night long measuring all the stars you want at all night long different time. You will see the distance between the stars are all times the same. So there is no.
No, and the north and the south.
Appearing. We don't care about appearing. As a new perspective is all time showing the.
Yeah, they always do that. Apparently, I mean that's what you'd have to show them. You have to show that they don't actually do that through some kind of like vigorous like some kind of proof that shows the star that doesn't converge from the northern star and the southern star without just like stating it. You can't just state it. I mean, this is what we see no matter what.
You do that with the
do
GPs. We have the GPs. We know the GPs work.
Yeah, and the GPs work out this way too. Yeah, the Weems and Platts official star wheels have them plotted. If you plot them out using the star wheels, they converge and diverge using the official Weems and Platts star wheels.
They do not diverge. Stop it.
Yeah.
Oh, you can just say they don't, but that's what the actual data shows. Sorry.
The ephemeris has a positive and negative, but yeah, I'm telling you, y'all are thinking about a God view. Look, just think of the stars that are close to one of the poles, but not at it. I mean, you see them one going west and one going east and shit. Like y'all act like they just do these perfect little things. You see them going in totally different directions if you're close to the center. I mean, what are y'all talking about, man?
I mean, you can't be that depth, dude.
Now positions of the stars don't converge or diverge.
Brian, yeah, they know how much of a Globe debunk this is. They have to just like state that it doesn't happen, even though it does.
Because it doesn't.
So here's the question.
Good job. You just proved my point. It does.
It does appear to empirically. It does. That's why I read the ChatGPT. It's admitted in the mainstream as well. That part of it, but they don't claim it's actually happening. They claim it's only appearing to happen and not actual. But that's why I brought up the train tracks could actually be converging in real life, or they could be parallel and it's just apparent. So that's where.
Yeah, but the train tracks are measurably changing an angular separation into the distance. The stars are never changing their.
Hey, Gio, did you notice some of those images?
Do the stars change their angular? Do any of the stars anywhere in the sky change their angular position relative to one another?
Look at that, Gio.
Question.
See right there? That's just like straight up at the equator. And it shows them like right there, even at the equator, they're converging and diverging. Like two circles meeting. There's no denying it. It's exactly what they do. It's a wide angle, fisheye lens. No one shows it right there, no matter what you say.
You see that with your naked eye too. I mean, that's what the stars look like.
You know those.
That's what they do. They have to deny it because it debunks the globe. Is a problem.
You know those fancy cars now that have the fiber optic star lights above the headliner. If you had that on the inside of a cement drum and you set up a wide angle lens inside it, even though those stars are not, they're fixed in the drum. And you did a time lapse, you would see the same exact pattern of the straight line in the middle and the right and the left converging and diverging.
You're moving the universe.
You would see that identical.
Yeah, you have to show them staying parallel. You can't show them staying parallel.
I'd like to see the ChatGPT thing that Gio just got because he says it's convert.
Look, I'm not arguing with the cement truck thing, dude. The cement truck, with a God view and the universe moving around us, you could make that work.
Can you post what you found?
I can go find it. I was pulling up Walter Bislin's thing because it shows the rotational stars because he pulled this data from Stellarium. Anyways, I was kind of playing with this for a second.
I don't think that the ground position
isn't that a great shot there, Gio?
Diverge.
That shows it like right there, converging, diverging, right there.
So I'd like to see that.
They totally converge and diverge. They have to say it doesn't.
No, it appears to because it's flat. It's nothing. They never change. It's so simple to understand.
Yeah, you can't ever show them running parallel without converging.
I'd like to see what do you mean by
StarTrails in the north and the south that do not do this. If they actually stay parallel, you should be able to show that. You can't.
They're talking about looking at the stars on the equator with the wide angle. You see the north and south in the same thing.
With a wide angle, of course, with a wide angle,
not a fisheye lens.
Appear differently than
only a fisheye lens would do that. We're not using a fisheye lens. The wide angle lens is not.
With a wide angle.
Yeah, but that doesn't make a fisheye effect just because it's wide angle. It doesn't make a fisheye effect just because it's wide angle, bro. You can't show them without doing that. You'd have to be able to show a regular camera showing no divergence and convergence, which you can't even do. And that's your claim.
Yeah, no, they absolutely do it. And even in the mainstream model, that's what's admitted. So Omnivore, I posted here. That's the ChatGPT. That's the first prompt I did. And it should be with the prompt and the response. Let me finish, please. Let me finish. Okay. Let me finish, please. Nobody interrupt. Don't do that at all. Okay, give me 20 seconds. All good. So that's the first one that I posted because you wanted it. So there it is. And then the second one, I said, I said, is this because of the train tracks converging type effect? And it says, yes, very much so. It's essentially a perspective effect, like railroad tracks appearing to converge in the distance. The important distinction is railroad tracks, parallel lines in 3D appear to converge toward a vanishing point because of perspective. And then this is what they're claiming. StarTrails, and this is why I pointed this out, I said it like 3 times, the whole, when I was using the, like I was saying, you could have train tracks that are actually converging, like measurably they are converging, and they're going to look like that. Or it could be perspective. And how would you know the difference? You go out there, you take a ruler, you can actually measure whether they're doing it or not to confirm. But this is where they're not doing that with the stars. They admit it's apparently happening, but they just claim really behind the curtain, they're not, they're not actually doing it because Glob, their theory, but they don't have a way to prove
By the way,
that.
we're
anyway,
at 40 seconds.
let me just
seconds.
finish. Please don't
We're at
interrupt.
40 seconds.
Let me finish the last
seconds
part.
of the 20 seconds.
Yeah, thank you very much. So anyways, the second part says StarTrails. The stars' apparent paths are circles around the celestial poles. When you photograph them, the projection of those circular paths make them appear to converge toward a point, producing a similar visual effect. At the equator, this is especially interesting because the celestial poles are right on the north and south horizons. So if you're using a wide-angle lens, the star trails can give you a dramatic converging lines appearance, even though the stars aren't physically moving toward a point. So the same visual principle perspective, but different underlying geometry. So at the end there, they did mention the star thing. And of course, if you have a wide-angle lens, you can get a more dramatic version. But yeah, this is exactly what's claimed.
Can you ask it within that same prompt, Geo? But are the stars within the field actually changing in angular separation between each other over the course of the night, or is the star field always fixed in all directions relative to one another?
That's the question.
Right. Yeah.
Ask it that question, because this is nothing more than the same thing that you would see in a cement drum. When we know the cement drum, that if you had stars inside it, like fiber optic lights in a Bentley, those stars would never change their relative position to one another, but you would still get the same effect on a 2-dimensional time lapse.
Yeah, but that's not exclusive to a ball.
Of course it is.
If we were inside a cement mixer, you'd be able to get the star trails without them converging and diverging. If it was actually a cement mixer, you have lots of opportunity. So I'm just running parallel without any kind of convergence divergence. You can't do that. So we're not inside a cement mixer.
So Gio, you gave me the screenshots, but what I was asking about was the ground positions, which do not diverge or converge. So yes, clearly, if you're using a wide-angle lens, you're going to see distortion. You're using a distortion lens. That's like saying if I look at a funhouse mirror and I see myself looking squiggly, am I actually squiggly? And the answer is no, you're not actually squiggly. But
okay, let me.
It's not a fisheye lens.
Understand this.
Not all wide-angle lenses show a funhouse mirror. It's just not a funhouse mirror lens. No matter what camera you're using, you're gonna see a convergence and divergence. You should be able to use a regular camera and show them not doing that, and you can't do it.
Hopefully this will help
I
you
don't know
understand
what's
a little
so hard
bit.
to
Like
understand
let's just. Can you guys hear me? Okay. Can you guys hear me? I don't know. Am I? Am I cut
Go
off?
ahead.
Nobody hear me? Oh, okay. I just want to make sure y'all can.
No,
hear
we
me.
can hear you.
So basically, yeah, the wide lens just helps you see the field more. Now, you could say, oh, it distorts. Well, let's say it just,
so what you're imagining happens is that those two stars will come together the way it looks in the wide angle lens, that they'll start further apart and then over the course of the night they'll get closer together. That does not happen to the ground positions. That is just an artifact of the lens, to my understanding.
Yeah, it's not a funhouse lens fisheye, bro. You can't show it without them doing that. You keep saying that, strawmanning it.
And we can test
no matter
this.
what lens you use, no matter what lens, they always converge and diverge. You can't show them.
Don't.
Yes, they do.
Well,
you can't
we can
show them
test
not
this.
doing that. Show northern stars and southern stars in a time elapse that don't do that. You can't. They always do it, no matter what, even to the naked eye.
We don't have to guess.
Yeah, but Dave, they're saying that. Hold on, let me jump in though, Dave. But what they're saying though. Their argument is that it isn't actually happening on the ground. Meaning, if you had with the dual pole type thing, if you had the stars that were like physically converging, like making a right hand turn on the ground, and then the other ones are making a left hand turn, like they would be, you know, at one point, I'm just going to make up a number. They'd be 100 feet apart. And then you go a little further, it'd be 110 feet apart, 120 feet apart, 130, until they split entirely. Is, you know, if
Yep.
you know, in terms of that. So I think what
Exactly. That's what they actually do.
what they're saying is that that
And that's
doesn't
what they
happen.
do. On the land, you can mark that. You could actually measure
They
that
do
on the
not.
land. But since you do it from the
put an
prime
answer to you
meridian and you're marking
Ernest.
degrees from the prime meridian, they could be fooled into thinking that never happens. Or maybe that Stellarium even has it reverse engineered to like calculate that it wouldn't happen if we were on a globe. But there's all these spherical reification apps that are either keeping them convinced or they know this is so damning to the
What are
globe.
you talking
They just have to
about?
keep claiming it doesn't happen.
I've just
Hold
posted
on.
5 different equatorial time lapses
Yeah,
that
let
show
Brian go
that's
ahead, Brian.
tracking the sky, with motion. And all of them, the star field is completely fixed.
We
There is
went through this
nothing
with the
moving in the star
equatorial
field.
mount.
You're right. Right at the equator.
Brian already shut you down with the equatorial mount claim.
Yeah, if you're right
He's
at the
using
equator,
an
you can't get
equatorial
that.
mount.
Look, if you're right at the equator,
Brian
you
already
get
told you why
or
that
if
wouldn't work.
Or if you move the universe around you like in the cement truck and with a God view. Okay, but here's the thing. Y'all would agree that the stars stick to a latitude, right? So if they stick to a latitude, we can't look down a latitude, man. So these parallel latitudes, you can't see down these parallel latitudes.
You ever heard of the
You'd have
nautical
to have
almanac?
you'd have to have around the corner vision. So you got this one that's turning, right? You got this one trail that's turning, so you can't, and then it gets smaller and smaller. So you're seeing the whole thing. That this ones at the equator going straight. You can't see the whole thing because it's going straight.
I don't know
So
what you mean by that.
Here's my point. Y'all are thinking in a God. You're thinking in terms of a God view. You're thinking in terms of these parallel latitudes, but in reality, they're not parallel, man. Everywhere you go, you're looking different.
They are
angles.
parallel.
No, they're not. No,
That's why they're
Oh
called.
my God.
Oh
Yeah, but this
Oh
is
my
what's
God, it's just what they always
Yeah,
do.
but this
Oh my
is
God, how could you think it's actually doing what they look like they're doing? You're so stupid. You can't even think that. That's so
No, but
funny.
this is what's in contention, though. I mean, this is what's in contention
course.
is the contour of the ground and how that relates to the sky. So that's why this is in contention for these reasons, like how the ground, you know, relation, and then we get into distances and mapping and coordinate systems. You know, that's the thing in terms of getting into the actual like details.
Yeah,
I was
and
gonna
it's
say,
not as
like I
cut and
said,
dry as
if
that
we-
either, Gio. It's not the sky, the ground. We're the
It's
observer as
pretty
well.
dry.
Is like
actually
one of
very-
the biggest variables in the whole thing, right? Is how we observe these things, right? And,
What?
yeah.
I tried to make an example, dude. If I'm at Capricorn and you're at Cancer, real quick, Omnivore. If you're at Cancer and I'm at Capricorn, dude, and we both we both turn 90 degrees and we set our mounts to do a 90-degree circle. Okay, we're both going to converge at the equator. If we had lasers coming out of our celestial or our equatorial mount, they would make a converging point through the sky. They would converge at the equator because shit changes from depending on where you're at, man. So if you don't think in terms of a God view or the universe moving around us, then it gets a little complicated, man. That's all I'm saying.
Brian, do you know what the nautical almanac is, Brian?
Yeah. Why doesn't it just go from 1 to 0 to 360? Why does it go? Why does it go positive, negative?
Okay, so
answer me that.
Because you're in different hemispheres, right?
Right. But why would they do that if they're all just tracking the exact same way, though?
Okay, so can we go back and forth a little? So the reason why this is totally cut and dried, as I see it, is because the nautical almanac has the ground positions, right? So either the ground positions converge or diverge, or the star's not converging or diverging.
You'd agree, though, that over Cancer, you see the sun coming in from the north, right? So if you were to put a celestial mount, it would do a smiley face. It would come in from the north. It'd get closer to over your head. It'd get right over your head, and then it would diverge back to the north, right? But
what's the axis?
If you're over Cancer, though, it would come from the south, is what I'm saying, dude. So what I'm saying is your points of view changes in your model. You're thinking just the latitude, the straight latitude.
I don't think you understand.
That's not how the globe works, man.
I don't think you understand how an equatorial mount works. Do you know what the axis of rotation is on an equatorial mount?
Dude, did I just explain the sun coming in from the north come into overhead.
What's the axis of rotation on
north.
What's the axis of rotation on equatorial mount?
You got to line up to Polaris, dude. You don't have an equatorial mount, dude. So you ain't even in this conversation.
What are you talking about? This is LXD75. Go look that up.
This is
okay. So you agree that to set up the Polaris and then to track to 23 degrees north. If you're, let's say, if you're tracking just like from, let's say, halfway between the equator and Cancer, you'd agree that the sun comes in from the north, gets close to overhead, and then diverges back to the north, and then opposite in the south, right?
Only in the summertime. The sun is only coming in from the north only in the summertime is the sun rising in the north.
What is the importance of the sun being north or south of the equator? What do you think the importance is?
No, I'm just trying to say that look, your perspectives change. If we both turn 90 degrees from you from the north and me from the south, if we both turn 90 degrees, our points of view are going to converge at the equator, man. We have different points of view, man. That's my whole point, man. You got to think about that. Quit thinking of a God view. Quit thinking of a God view in straight latitude lines.
No, it's not the God view. The view that I'm interested in is the objectively correct ground positions. We know the ground positions work because you can navigate by them.
Okay, a better explanation is if you understand how an equatorial mount works, you understand there's only one axis of rotation on an equatorial mount, and you can aim it at any star anywhere in the sky, at any celestial object in the sky, whether that's at Polaris or on something on the ecliptic or any object, and it will track it over the entire course of the night from sunrise to sunset, and it will never move out of the center of frame. It will never. What do you mean you have to use two of them?
You got to use two of them to compare like north to south, dude. You can do the north or the south.
You understand?
You can't do both at the same time.
If the stars were actually converging and diverging, you would never be able to do that with one axis of rotation. You would need two axes.
Try and set up the Polaris and then track a star trail in the south, pal. See how that works for you.
Jack, one thing I think they missed is that when you set your equatorial mount, you fix the axis of rotation from one celestial pole to another, and after you turn your telescope anywhere you want, and after you will turn the telescope whatever direction it is looking at, around the axis of rotation from pole to pole.
That's the problem. The celestial sphere is different than your supposed ball. That's the difference.
No.
What makes it different? What makes it different?
We know that we're stationary, and there's
we don't know that.
Sure, but it's stationary. Look, it's one.
You know that. You know that.
I do it. Look. I'm trying to side with you here. I'm trying to side a little bit with you. I do believe there's one rotation because there's one sky, but it works like a magnetic field to where, and even in your model, they tell you this, that the field lines come up and they work their way around and back through in your model, right? Well, imagine that with just a hemispheric arch ceiling in our model, or my model, I guess you could say, like a firmament. It would work the same way visually, right? But magnetic fields are the key here. Yeah. Go ahead.
Okay. So first off, I don't agree with the magnetic field explanation. That's not quote unquote in your model. That, from my perspective, I understand what you're getting at, but it's a non sequitur. Okay. What the sky is doing and what the Earth's magnetic field are doing, according to science, are two entirely different, unrelated things. So saying that one of them applies to the other, I don't think that's correct. I don't think you can make that claim as, trying to smooth it over. I don't think that works. Secondly, I think that we have extremely hardcore understandings of how the sky moves, right? And it because of centuries of observation, and we know how the sky moves. Just a minute. And we have extremely good data about how it relates to the ground in latitude and longitude. Okay, so
yeah, but think about this.
So saying that the sky is moving and the ground isn't is just begging the question. it's much more parsimonious to say that the Earth is spinning because that explains all this shit. But if you don't accept that, if you don't wait, I'm almost done. If you don't accept that for some reason, that's fine. You don't accept it, but it doesn't make it. It doesn't make more sense to say the sky is moving than the ground is moving.
Equinox itself debunks the globe, dude.
You didn't attack my claims there, buddy. But go ahead. Yeah.
Let me say this: Equinox itself debunks the globe because the sun rises due east and sets due west on equinox for supposedly everybody. Let's not get right up on the poles, but for everybody else now. Now I went and checked this myself when I first heard about flat Earth. I was by equinox. I went, set up a string, set up poles in the ground. I got pictures of it, and it sure enough rose due east. Well, now if you go to Google Earth now, and I point, if I'm rising the sky, let's say 10 miles, and I got laser beam eyes, and I see the sun rising, okay, and from Tropic of Cancer, my laser beam is going to converge with the sky just over the equator. My laser beam is going to go right over the equator. If I keep going straight with it, it's going to go over the south and then off into space. Now, from the southern hemisphere, if you're trekking due east, and you got laser beam eyes or laser beam pointing right to the sun that's rising, it's going to do the same thing. It's going to go right over your head at the equator. They're going to crisscross, okay, and then go off into space. So you can't have suns crisscrossing. So just the equinox itself debunks a globe, dude.
That's just your misunderstanding of geometry is all that
it
is.
That?
Go to Google Earth, okay? Draw a 90-degree line from Cancer and then from Capricorn at the same longitude. Okay, go about 6,000 miles, which is about how far that y'all claim it is. Okay, now both lines are gonna converge at the equator. So if you were at the equator, you'd see that laser beam go over your head, right? Because of the globe, you'd see it go over your head and track in outer space. Okay, so like I said, it'd be two different points in space, man. So y'all are thinking that from a God view. You're thinking about these parallel latitudes, right? But that's not how you see on a globe. From a globe, everywhere you go, you're seeing a different angle, dude. Y'all ain't
it's a long about way of saying that you're noticing that if you're living in the northern hemisphere, even on the equinox, you'll see the sunrise due east, but then it'll swing to the south of you and then set due west. But if you live in the southern hemisphere, you'll see the sun rise due east, swing to the north of you, and set due west, right?
No, my line of sight, a straight line, a geodesic, due east, whatever you want to call it, a geodesic from Cancer and Capricorn are going to converge at the equator. Okay, so that represents a line of sight. Like I said, if you go up 10 miles in the air and watch a sunrise, and then fire a laser beam right to the sun, you're going to be 90 degrees on Cancer. So at first it's going to be right on Cancer, right? But then it's going to start diverging toward the
or whatever, and then the edge of the table's out of focus, but then you see the images behind it on the table. I've seen a similar effect to that.
You could scoot
any of them lines out into space. They're diverging. They're crisscrossing, dude. Like I said, y'all are thinking of latitude line. Listen, you don't let me say this, dude. This is the crescendo. Y'all are thinking about latitude lines that are parallel from a God view. That's not the way perspective works on a globe. That's not the way 90 degrees works on a globe. You need to think about that before y'all keep making this argument. But I understand what y'all are saying, though, man. And but y'all should think about that, man. Yeah, go ahead.
So, yeah, Red Cloud. I'm not taking that from you, especially. Sorry. So, Brian, when you're talking about God's eye view, what do you mean by that?
Seeing parallel latitude lines. You can't look along a latitude line, dude. Only at the equator. It's the only place on Earth you can look along the latitude line. Once you diverge from the equator, you got to have around the corner vision to see along the latitude line. Only works at the equator, dude.
What do you mean by that?
The stars stick. Well, the stars stick to latitude. So if one's at 5 degrees latitude, it's going to stay on 5 degrees latitude. You can't just sit there and watch it. You can't watch it go in a straight line. You can't because latitude's curved, dude.
So what he's saying is it's because only the equator is the only great circle in latitude. That's what he's saying.
Right. You can't look straight down a latitude line. You just can't, except the equator. So in other words, if you're tracking a star, or if you're traveling it, you got to turn.
I don't okay, so what does I still don't understand the point. What does you can't look down a latitude line mean?
Well,
Jake, do you know
you
what
got to turn, if you got to think about this, if you got to turn, okay, and you're in the north and I'm in the south, then we got to turn away from each other because we got whole different perspectives.
5
So like I
degrees
said, you can
north
argue
and
the
5
perspective
degrees.
thing. Yeah, the closer you get to the equator, the closer you're getting back to your
What he's
God
saying
view.
is,
I give you that.
what he's saying is because only the equator is a great circle. Any other latitude line, like if you were flying in a plane, you'd have to be turning left or right to follow that latitude line.
Okay.
But the difference between 5 degrees north and 5 degrees south is constant. There's no difference. They don't converge and diverge.
They don't. The
Okay, draw a straight line. Then draw a 90-degree. Then draw a 90-degree line on Google Earth and see where it goes. Okay, tell me they don't
Follow it all
converge.
the way around the globe. We have
No, he said it really harshly, Brian. He said it really strongly. He said they don't, so they must not. Even though that's what we always get, no matter what, they converge or diverge. You can never see them not doing that. But that's what they don't do, huh?
No, I understand what he's
saying. Hold on, he thinks you could look along Cancer and see all the way around, just a straight line.
I understand what he's saying. The ultimate way of what he's describing is that if you were at the North Pole and you were on a latitude line that was 5 feet away from the North Pole, it would be a circle around the North Pole. So you'd constantly be having to curve in order to follow that latitude line. That's what he's saying, that you don't have a straight line of sight to it.
Okay. Okay, so I can see along a latitude line for some distance. It's just that eventually, because it's not a great circle route.
Sure.
Okay,
Right.
It's called a small circle.
So when
It's
so that's even stronger evidence that what you're saying has a problem. I understand the point that if you're close to the pole, it's going to be but you can certainly see along it. I can turn east and look east, and I can see a long way east. Okay, so when the stars, because the stars are in a celestial sphere and the Earth is a sphere, you don't have to believe that, you don't have to agree with that, but in that case, in that model, which is the model that I think makes sense, then the stars don't have to converge or diverge to follow around the lines of latitude and longitude. In fact, they never converge or diverge, and we know that.
Well, that's what's in contention,
right?
Apparently they do.
No.
That's why even in the ChatGPT thing I read earlier, that's why I kept saying, like, just to say it again, but like the train tracks, they might be parallel and they look like they're the train tracks might actually be parallel, but they look like they're converging. Omnivore, do you have me muted?
Train tracks, you can measure it, Gio. You can measure the angular change of the train tracks into the distance, getting smaller and smaller. There is no angular change in the separation between stars. That's why in every single equatorial mount where the camera is moving with the star field doesn't warp in any way. It stays completely static.
There is a freaking toward the horizon. There, it not only spreads out a little bit, not a lot, I'll grant it, but it also bunches up, man. What are you talking about? I mean, that's why they don't use stars close to the horizon.
Do you know what an equatorial mount is?
They're not.
I mean, he's talking about
God,
when you're within like a degree of the horizon, there's going to be some refraction that can cause the stars to appear to bunch up and slow down because they're being refracted.
No, not a degree. More like about 15 degrees. More like about 15
Are you
degrees.
talking about the
No,
are you speaking of periphery stars, like you're setting your equatorial mount to a center star where you're wanting it to focus on, like, you know what I mean? But the periphery stars, just like the way you see, like, you know, that they curve backwards a little bit. They've got a little bit of a curve. But the one you're focusing on will follow. Is that what you mean by the equatorial mount and all that?
No,
you were talking about Stellarium, man. Stellarium represents an equatorial mount, and you see the slight divergence. Like I said, it's not a lot, but you see it even in Stellarium.
Mm-hmm.
Jake posted 7 videos in the chat of an equatorial mount. I don't know if you guys understand what it is.
Yeah, I mean, go into detail for
us.
I know what it is.
Yeah, it's not. It's not really actually related. ultimately.
It is
How about I
related.
use a stick in a how about I use a stick in a shadow? Okay, you put one at 10 degrees north. I'll put one at 10 degrees south. Okay, and we can't have the sun at both places at once, but we can have stars, right? So pretend the stars make shadows like the sun. Okay, if you got a star coming over at 10 degrees, you're gonna get a smiley face measured with a fucking shadow, dude. And if you're in the north, you're gonna get a frown, dude. It measured with a shadow, bro. So 10 degrees north, 10 degrees south. You measure if the stars could shine like sunlight, you'd get a frown and a smiley face. Granted, it's not much, dude, but it's there,
Yeah, but
dude.
and even in the mainstream model goes
So,
against what you guys have been arguing
I don't-
for what. Omnivore, can you hear me? Okay, apparently you can. So, anyways, even in the mainstream model, they claim that you can measure the degree of angular separation apparently of the two rotations. So I'll just read this. I mean, I already knew this, but you guys were asking for ChatGPT, and I had it pulled up earlier, so I did another prompt just for fun. And this is what it says. It says yes, the apparent angular positions of stars can be measured, but there's an important distinction between angular separation and actual distance. If you're at the equator and compare the northern and southern stars, their angular separation on the sky changes predictably as Earth rotates. In the time lapse or long exposure, their trails can appear to diverge or converge depending on where you are, where in the sky, and how you're projecting the sky onto the image. You can measure this in degrees of angular separation using the star's celestial coordinates, right ascension declination. However, the stars are not actually moving farther apart from each other in space as a consequence of this effect. So they're basically, I mean, in their model, they're saying that out in space, light years, whatever, they're not actually getting further and closer in their model, which we all know that's what they would say. But because of the apparent effect, which, like I said, in the mainstream model, they essentially claim it's a perspective type effect, they are appearing to diverge and converge. And yes, you can measure the angle of two stars, like a star in the north and a star in the north. Actually, that angular effect will be measured. They're just claiming it's an apparent angle, of an angular separation. They're not saying it's actually happening out in space, but they even admit it is happening on the ground.
It's
that you
slight,
can
but
measure.
it's measured. It's slight, but it is measured. Like I said, stellarium represents a EQ mount, dude. It's slight, but it's measurable, man.
I mean, it all goes back to the fractal nature, man, of everything. Every system on Earth, bro, down to molecules, electrons, higher order harmonics, octaves, and shit, man. It's all connected. It's all connected. But anyway, that's a nonsense.
Like if you pointed, if you pointed at a star in the northern, like if you're on the equator and you pointed at a star, let's say 45 degrees north, you point at a star in 45 north, because you're on the equator and you're pointing to a star in your sky that is at 45 north. Then that's one with your right hand, you're looking west. Then with your other hand, you point to a star 45 south, and then you follow those lines. Your arms will have to physically diverge to keep following them. Your two arms are going to have to get further apart. Your muscles are going to have to actually spread in order for you to continue tracking them. And that's what's being referred to.
Yeah, just
is a divergence, and that is
a little bit.
A little bit, yeah. It's going to be slight, but that's why I was saying earlier. If you pointed at the Big Dipper and then you pointed at Sigma Octantis, of course your arms are going to diverge from each other if you kept pointing at them, because we know that they're going around one's clockwise, one's counterclockwise. They're obviously diverging and converging. That's what counterclockwise and clockwise is. It's just that the Glob model says that that's not happening on the grand scale.
I gave it.
It's not much.
I gave ChatGPT
it's not much.
A more specific prompt, and here's what I asked it. I said, in time lapse of star trails, the stars appear to diverge and converge, but does the angular separation between the stars actually change over the course of the night? And it says, no, the angular separation between two stars does not change over the course of a night. Earth's rotation makes the entire celestial sphere appear to rotate as a single rigid body. A rotation preserves angles, so if two stars are 5 degrees apart, they remain about 5 degrees apart. If two stars are 40 degrees apart, they remain 40 degrees apart through the night. So then why do star trails look like they diverge and converge? That's mostly a projection effect. A camera converts the curved celestial sphere into a flat image. As the stars move across different parts of the sky, their positions on the flat image don't behave like a simple rigid rotation.
Now, could you
that's the whole point.
Could you ask it the difference between what you just asked it and then add in on the equator looking due west. The effects. Because that's the key
Yeah, it's
factor.
not really different than what's been mentioned because the
Did you
angle
not hear the
between
last
them,
part of what he said?
like the stars between
Yeah, but I want a
each
source.
other are not. Yeah, it's the northern and southern rotation that are diverging. The stars in relation to each other are not converging and diverging. They're in like that's why they're called the fixed stars. They're like I was saying like a tapestry. They're like a tapestry. It was using different words, but I don't think anyone's really contesting like the tapestry nature of it. We're talking about the apparent
A single
observation.
rigid body, Gio. That means that the stars never actually change in their position. It's like a single rigid body. Like I said, like the inside of a cement drum. If you were to put little stars on the inside of a cement drum, they would never change their position to one another. But you could set up a wide angle lens in there and you would see the same, exact convergent and diverging that you would see in these time lapses.
Nobody's arguing that, bro. You keep
What's
saying
so hard to
that. Nobody's arguing that.
Let me ask him this. Let me ask him this. Well, hold on. You're asserting with this mind practice you're trying to get us to do with the drum, the concrete drum. You're stating right off the bat that there's only one field of stars, or just one dot in circles or something that's rotating.
Not stating any of that. They're not
Hold
stating
on. He
any
just
of
said. He just said inside the drum with a bunch of dots on it, like it's attached to it. There's only one possibility,
No, you're just making.
I don't think you understand what he's saying.
Hold on,
can we get closure on that previous argument?
All right, you guys, let's let Gatebreaker go.
Can we get closure on that previous argument? Whoever read those two AI outputs, that was correct. This isn't the time to just for more attacks and more side arguments.
It was Jake who read it. It's 100%.
All right, what do you want to get to the bottom of?
Test that. I would say if you can see the StarTrails converge and diverge anywhere, any place on Earth, then you should be able to see that any place on Earth, not just one location. If it's one location, there's something unique going on there.
Bro, you're just fucking.
That's where they're going wrong. They're using a God view. That's what they got in their head is a God view.
No, it's nothing to do with the God view.
Globe perspective.
It's not
everything
a God.
To do with the God view.
What does that mean?
Bird's eye. Yeah, external.
Like I said, if we turn parallel at Cancer and Capricorn, 90 degrees, we converge at the equator, man.
Yeah, it's not a great circle route. I get that. What does that mean, a God view? How do you figure that's a God view?
You're picturing these parallel latitude lines from just one position, dude. But that's not how we see on Earth, dude. Like I said, you can't see along the latitude line, only the equator. You can't see straight. You don't have a straight line of sight above Cancer, Capricorn.
That's not true.
They turn. They turn, dude. Yes, it is true, dude.
On long distances.
If I'm trying to,
that's what I'm talking about. Long distances.
If I'm trying to fly a plane, okay, and I'm holding the wings level, then yeah, it's going to go in a great circle route. If I just put it west and lock it on there, it'll go around the latitude. Okay. So if I'm always flying west relative to the geographic North Pole, it'll fly right around the latitude. Now, it won't, the wings won't be level for that. You're right. But none of this matters. This is not a God's eye view. This is how things work with a celestial sphere and a ground sphere. Okay?
I'm picturing it with God's eye view.
Well, that's what the ground positions of the stars tell us is happening.
And it's all mapped in.
We need to do some more StarTrails. We need to do some more StarTrails because I can pull some up and show you, dude.
Did you hear what
little bit of deviation? I'm not talking about the arcs at the North and the South Pole, but even they slightly deviate. Every arc slightly deviates toward the horizon, man. It's not that much, man, but it's there, dude. I'll show you some StarTrails. Looking southeast from like California you'll see the stars straighten out at the equator and then start to turn. It's not a wide angle lens. It's not much, but it's there, and you could call it perspective or something, but y'all can't ignore it, dude.
Also, Omnivore, I have a question. You believe the stars are really far away in the globe model? Like
Yes. Yes.
Yes.
Okay. Now you know from a single point source of light, as it gets further away from you, it converges, right? Compresses.
What do you mean?
Towards the source.
Okay, so
yeah.
Try again. What is it? What are you saying?
So if you're on Earth and you're looking at a star that's, let's just say, a light year away, right?
Right, yeah.
Is that okay? A light year, okay. Now you know from your perspective where you're standing on Earth that as you get, well, I'm just saying, as you get closer to that light, the light source or light rays will converge back to its source, right? Meaning vice versa. If you're on Earth, hold on 1 second. If a star a light year away is and you're standing on Earth and you know that the light rays will converge back to that point. Okay, listen. Then it's fair enough to say that as light travels towards you from that source, the rays will diverge, right? So I'm curious how y'all get an accurate, representation of that star. Hold on 1 second. How do you get an accurate representation on the ground here on Earth if those light rays diverge?
They don't.
Good question. Good question. Okay. So the way the reason why it works is that this is how let me see if I can find. I have a Blender file that will show this. So this is why celestial navigation works. And it's a great question. So what's happening is the light from that star, which is super far away, is expanding in a sphere. By the time that light reaches us, you can think of it as a flat plane, okay, as a set of parallel rays that are coming into us. Okay,
that'll be no problem, by the way. We think of it as a flat plane because it is
by 1 degree per 60 nautical miles.
You have to add or subtract depending on what side of the
That's why we can see the star. The light rays.
In the math, though, you have to add or subtract. Depending on what side of the equator the
sphere is so large that it's like essentially a flat plane of parallel beams coming in from the star. So they don't all track back directly to that star, or they do, but at such a long distance that they're by the time they're reaching us, they're like literally, because people have done the math for this.
I agree.
1/1,000,000th of a degree off.
Yeah, they're almost
parallel. Stars are laser beams.
So do you understand? Did you understand that answer, artist?
The fact that they're so far away, you shouldn't see them separated at all. Actually, because they're so far away, you would never get that.